1, then run these lines. I'll just select them all and hit tab to jump them in. Then, as I mentioned, we need the else part, what to run if it wasn't equal to 1, and that will be an empty block for now, since we don't want anything to happen if the selection is not exactly 1. In this case, we can actually just omit the else part. The if then else system is designed so that if there's no else part following the basic block here, the main block, then it will just go on as if there's nothing to do in case the condition was false. So now the case of an empty selection is foolproofed. It won't crash our script, supposedly, but let's try it. I'll save it and evaluate it. Minimize the script, remove the previous trees, deselect the plane so I have nothing selected, and well, let's see. No error message and nothing happens. Since basically if the selection count was not exactly 1, our script just goes through the whole code and nothing happens. It just skips everything. Okay, but what if we have one object selected, but what if that selected object doesn't have any vertices? What if it's a camera, for example? Let's try what it would do. Let's create a camera, free camera, for example. So now we have one single object selected, so the script will run. And there's an error message again. Cannot get mesh from this object, free camera. Okay, so we have to make sure our script only starts generating trees in case the selected object has geometry. Lucky for us, since only objects derived from the geometry class have geometry, quite logically. So all we have to check is whether the superclass, the parent class of our currently selected object, is a geometry class or not. If it isn't, it certainly won't have any mesh. So this will require an additional conditional statement, which will look something like if superclass of, that was the function that gave us back the superclass, the parent class of the object passed to it, which will be the selected object, equals geometry class. Then actually we should put this inside here, then run the whole block. Oops. There. We had to put this conditional statement inside the selection count check, because if we put it before it, we would actually be using the $sign variable, which could have anything in it. It could have an object set, or it could have an undefined value in it. So we should put it inside the selection count check when it's already safe, when we already know that it only has one object in it, which is the actual object that we have selected. So if the superclass of the selected object is of geometry class, then go ahead, because then it's going to have a mesh property. Basically, what happens here when Max evaluates this condition, it gets to the brackets, right? So at first it will evaluate what's inside the brackets. It will find this function call, superclass of, which function will expect an input variable, which is the $sign, which has this currently selected object. So on the left side we will have the superclass of the currently selected object as a value, and then comes the equal operator, which compares the left side to what's on the right side. So if the superclass of the currently selected object was geometry class, we would have geometry class on the left side and geometry class on the right side, and then MaxScript would go ahead evaluating the code inside this block. So In theory, we can now freely use the script and hopefully it wouldn't fail on us. We tried to avoid obvious misuses by foolproofing it a little bit, but you can't always think of every possible problem that might come up during usage, so chances are there's still a couple bugs in there. But let's try it now. Save the script, evaluate it to reinstall the new foolproof version, and let's try to run it with the camera selected. Nothing happens. Let's try to run it with nothing selected. Nothing happens. Let's try to run it with this plane selected, and there you go. There's our forest. I'll just remove them. I'll modify this plane a little bit to make it more interesting. Let's remove this camera, we don't need it anymore. Let's make it a little bit bigger. More trees. Like that. Let's add a noise modifier on it to make it a little bit bumpy. Like that. So since we were using the dot mesh property of the selected object, we are actually getting the mesh from the very top of the modifier stack, so it will have the noises effect. So if I create trees on this object, you can see that they're all placed nicely on the surface, even though it's all wavy and distorted.